Good afternoon, everyone. Welcome back from lolly break. My name's Pete. For those of you who weren't here this morning, for my first session, I've been working with Windows systems primarily as a sysadmin for over 20 years. Recently, I've handed off that hard job to other people and have been doing training and consulting instead. If you want to tweet questions or other things for this particular session, please use the #SVR412 tag. I had a lot of comments and other things from this morning's session, and I think I've addressed all of the things that came up from that. I know this session is also labelled SVR-VIR412. There's an extra 4 characters you can get if you don't use the -VIR on Twitter. Welcome to the impact of cloning and virtualization on Active Directory domain services. And I didn't eat my chips before that because I thought I wouldn't be able to say that with a mouthful of chips. What are we going to cover? This session was presented by Dean Wells, who's the Senior Product Manager for Identity and Access in the Identity and Access Group in TechEd North America. And I liked it so much that I thought we should have it here. However, where it belongs is a problem, and the level that it exists at is a problem. It belonged in the security track because it dealt with identity in the US. Here we've placed it in both server and virtualization because it touches on each of those. And what we're recognizing by this fact is that some of the things that we learn at TechEd don't neatly fall into the little boxes that we have on the tracks. So there will be some concepts in here, if you are from the server track, that you might be very familiar with. There'll be other ones that if you're from the virtualization side of things, you will be familiar with. So we've pitched this at a 400 level, but it probably exists somewhere between 300 and 400, perhaps closer to 400, depending upon what sort of knowledge you've come into the session with. First up, we're going to be digging into what is Windows Identity about, particularly as it relates to servers. In particular, as it relates to domain controllers and how we can get some issues caused in the virtual environment. Secondly, we're going to look at Active Directory replication and some of the issues that can be caused in a virtual environment. Just as a show of hands, how many people are actually virtualizing domain controllers here? Goodness me, just about everyone. All right. Hands up again if you are snapshotting those domain controllers. Well, only a few hands up. Cool. This is in particular for you guys, but I think everybody can take something from this. We'll also finish off with a few other things. We'll see how the time goes. We finish off with the time sync service and a few other miscellaneous considerations. But the bulk of our time is going to be spent on identities and replication. But first up, a computer identity. A lot of this should be familiar to you. Consists of a name, and we store the name inside AD with a $sign on it to indicate that it is a computer account. We have an IP address, which we use to locate said machine. The marrying between the name and the IP address occurs in DNS. Thank you very much. You can read. And we have SIDs. What does SID stand for? Security Identifier. We're all on the same page. Fantastic. Let's dig into SIDs in a little bit more detail. The protocol documentation that the Identity and Access Group are responsible for developing contains all the information that is required at a detailed level to understand what is happening protocol-wise on the wire between machines in the Windows world when they talk to each other. The only more detailed aspect of how Windows replication, AD replication, and security between machines operates is the source code. The protocol documentation is actually available online. You can get it free through MSDN. So if you're having trouble getting to sleep at night, That might be something that you can use. It contains enough detail for third-party vendors to actually be able to produce their own domain controllers. That's the level of detail that it contains. So this information about SIDs is straight from the protocol definition. A SID comprises 3 basic blocks. The first block is really just to say this is a SID. The S means nothing. The 1 and 5 are just version numbers. The green numbers here, starting with 21 to indicate this is based for a domain, identifies who is responsible for managing these identities. This is randomly generated when the machine is created, and we'll talk about how the domain SID is generated as well. The last portion of the SID is called the RID, and this is to allow for multiple identities to be stored inside the same account store. Seeing nods, people are with me. Fantastic. Let's keep going. How are the machine SIDs assigned? They're actually assigned, said, when the machine is either first installed, or if you run sysprep and do the generalize, it wipes out what might have already been there and will generate a new SID for the machine. This is a local SID. This is an identity for the local authority on that machine. So if you are creating local users and groups on a machine, they will have a SID that has a portion of it for the account store for that machine. Now, when we join a machine to a domain, it gets a domain SID. Question: does the domain SID replace its local machine SID? No. In fact, the machine now has 2 identities. It is aware of its own identity for its own local store, and it now has a new SID that it uses for all authentication purposes on the domain. There is one exception. If you promote a machine to being a domain controller as the first domain controller in a new domain, it is going to take its SID and change that SID into the domain SID. So we'll only have one SID. Secondly, if you take another machine that it's got its own SID and you promote that machine to being a domain controller in an existing domain, it will wipe its own identity. It will no longer have its own SID. It instead replaces that with the identity of the domain. This is actually quite important. This is so that domain controllers understand that the only accounts that they are responsible for looking after are the ones that are domain-based. That is the only account identity that they recognize. We're going to go through a few little deployment scenarios just to see how SIDs actually impact on whether machines will work. So let's start with we've got a machine that's been joined to the domain. It's called M1. It's a virtual machine. We take the machine's VHD and we copy it. Do you know that you can copy the VHD while the machine is still running? That's a scary thought. We take the VHD, we copy it across, and we create a clone, a new container, a new virtual machine, and we just attach the VHD to it. We boot it up. Can these 2 machines actually exist in the same domain at the same time? Who says yes? We've got probably a third of hands. Who says no? Got a third, and we've got those who say yes, but there are conditions. And we've got a few people who are quite not sure and don't want to commit either way. All right, the answer is yes, for a while. Both of the machines will have the same name. Let's assume that the IP address has been fixed up through DHCP. They will want to talk to the domain controller to be authenticated on the domain. They have, in their registry, obfuscated through their registry in 16 2-byte packets, the components that make up the shared secret that it uses for its password. It pulls that all together, reconstructs its shared secret, talks to the Kerberos server and says, here I am, please give me an access token. And the Kerberos server has a look at the shared secret that's been handed to it, compares that with the name that the machine is presenting and says, yes, this is the shared secret that matches with the name and your SID. Here's your access token, go for it. Now these shared secrets get changed. Just as we like to have users changing their passwords on a regular basis, computers will update theirs as well. And by default, I think it's about every 30 days. It used to be 7, then 10, then 14. I think it's around 30 days now. At the 30-day mark, one of these machines is going to say, I need to change my password. I probably shouldn't say change, because what it actually does is it resets the password. It generates a new shared secret, connects to the Kerberos server to say, I am who I am, this is give me the access token, and then talks to AD and says, here's my new shared secret, reset my old password with this one, blang. The next machine that's still quite happily running, it's previously been authenticated, it's got a ticket that says, I'm actually allowed to talk to AD. It goes and generates a new shared secret. It goes to the domain controller and says, please reset my password. Blang. And it works. And these two machines are still quite happily sitting there, running along for a while. When they'd reset their passwords, they might have gotten a new access token until it comes time to either restart the machine or it needs to re-authenticate against Kerberos, at which point the first machine is going to get an access denied. Because it's going to say, here's my shared secret, give me an access token, and Kerberos is going to go, no, that's not right. So, yes, but. That's not me. Okay. How about if we take one of those machines and offline we remove it from the domain so that we're not removing that computer account in the domain. We rename the machine and then we join it back into the domain. Will that work? Yes. Now, the machines still have the same local security identifier. They now have different domains. And from a purely Windows and AD perspective, these machines are fine. I am aware that there are some other third-party and some other Microsoft applications that might be looking at the machine SID, but from a purely Windows and Active Directory perspective, these machines are now fine. They've each got their own name, they've each got their own domain SID, they've each got their own shared secret that they are using to be authenticated, all good. Let's jump in the deep end. Yes. Don't need to. If we do it before they, when we said offline remove, do we also reset the computer account? If we do it before they go and reset their shared secret anyway, we're all good. So once we bring up the clone, they're both on the domain, we can then take it off. The first one is still actually active, or we could do it with the second one. The first one, which is now no longer able to connect, we take that off the domain, offline, remove it, rename it, put it back on again. Does that answer the question? So we don't need to reset the computer account at all. One of them is always still going to be able to authenticate. In that case, the second one. We leave that one alone. Right. Sorry, your question.
So when you clone that...
Yes, when we clone it.
You put it offline and say, but the machine still stays...
The machine SID is still the same, yes.
Is that a problem?
It is not a problem for Windows and Active Directory. It could well be a problem for other applications, but from a Windows and Active Directory perspective, it is not a problem. How many of you create Windows servers from like a template virtual hard drive? Quite a lot of people. Do you generalize it first? Do you use sysprep and run generalize? Yes, good. I'm assuming that we're not doing that. We should be generalizing it. However, Microsoft does have documented cases where people are going to be doing exactly this. They're not actually running sysprep with generalize on it. We take a VHD, fully installed Windows server. We take that VHD and we create a domain controller. We create a new virtual machine. Now, just for the sake of clarity, we've used S20 here to denote the account authority portion rather than the full string that it would be. So this machine, S20, has been promoted to being a domain controller in a new domain, in a new forest. We then have a new install. We're not using the template here. We have a new install of Windows Server, and we create a new domain, which is a child domain of the first domain. The reason why we can't use the template is because, as we said, when we promote a domain controller, a machine to being a domain controller, it will try and create a domain with the same SID as what it previously had. And AD won't let that happen. We then go and grab the virtual hard drive again and we create another virtual machine, and we put this machine, we join this machine to the child domain. This is all fine. This works. This machine will now get a domain SID that is S-10. Its local SID is still S-20. We create a group in the child domain. We call it Super Mario Brothers. It's got a SID that is in the S-10 account store. And we give this group read-write access to a share on the Luigi machine. We put the administrator of the parent domain into that group. So far, everything works. There are no problems whatsoever. What happens, though, when the administrator of the Peach domain logs onto a machine that is in the Peach domain and tries to connect to luigi.princess.peach.com/gameboy? Now, I'll tell you what happens. He's going to get an access denied message. The question is why? Every other member of the Super Mario Brothers group in the Princess domain is able to access this share. No problems whatsoever. The issue comes because the token that is created, the privileged attribute certificate inside the Kerberos token that is provided, that is built in the Peach domain for the administrator, will contain a number of fields. Those fields include primary user, the owner of the token. The owner of the token, in this case the administrator, is S-20-500. It's their SID. It will also contain in that token all of the SIDs of the groups that that person is a member of, including S-10-123. That token is passed down to the princesspeach.com domain. The Kerberos server there packages it up and encrypts it using the shared secret from Luigi, and then passes it across to Luigi. Luigi opens it, and he has a look at it. And before he starts determining whether or not people can have access to the share, he needs to evaluate the token. He opens up the token, and he has a look, and he sees, right, primary user, S-20-500.
Houston, we have a problem.
The problem is that this machine knows that it is responsible for S-20. Its local account store is S-20, but it has received an access token from elsewhere. So what it does is it says, I have detected an elevation of privilege attack here. And it does SID filtering. Now, some of you might be aware of using SID filtering for doing domain forest trusts or trusts between domains for passing accounts from one to another. And SID filtering is used to filter out SIDs that shouldn't be passed across that trust. That actually came from SID filtering inside Windows systems. All Windows computers will do it and have been doing it since the early days. It'll have a look at this token and go, right, this token here, S-20-500, that's not right, so I've got to SID filter that out. I remove it, and what I'm left with is an invalid token. I cannot have a token that doesn't have a primary user. Reason why? Let's say we have somebody who goes and deletes 1,000 accounts or deletes 1,000 files, and we're auditing those events. If we SID filtered that and removed the primary user, the person who did that, how are we actually going to find out who did it? We can't. So Windows won't allow that to happen. So in this case, troubleshooting this would be really, really tricky, but we're going to get an access denied. Scenario 3. We'll set up a machine M1. We clone the machine, so we take a copy of it, and we call it M2, so we're resolving the name issues here. We then promote both of those machines to being domain controllers in new domains in new forests. So they're not connected in any way, shape, or form. We then try and establish a trust between them. Is this going to work? No way in hell. Last one. We take machine M1. We create a domain from it called dom1.lab. We put a new machine, M2. We clone M2 to create M3. We put M2 into the domain and promote it to being a domain controller. We then try and join M3 to that domain. Remember, it's got the same local security ID as M2. Will this work?
Yes.
Yes, and the reason why it will work is because M2's local security ID is wiped and replaced with a security ID for the domain because it is now a domain controller. In fact, just on the last scenario, a little tip for those of you who might need to do this from a cloning perspective. If you do want to set up a trust between two machines that have operated from a clone, before you actually set up the trust, get the second machine, DC promo it down, DC promo it back up again. When you do a DC promo down, it will regenerate the security ID of the machine. It's actually quicker than doing a sysprep/generalize in many cases. In that case, forest2.com would have a different security ID, and we would be able to join the two together. Okay. So we're all covered on where local security IDs fit into the picture and how it can cause problems when we copy the VHD file and use it as a basis for cloning machines in our environment. We're now going to switch over to some Active Directory replication issues. First concept is update sequence numbers. Now, Active Directory has this assumption that time flows in one direction. You'd think that would be a fairly sensible assumption to have. There are two clocks in the domain controllers, essentially. There is the system clock that keeps track of time, and we know that if we are connecting to a time server somewhere, that if we are out of sync, we can slow the clock down if we're ahead of time, or we can speed up our clock to match our time service. That's all fine. That's only going to happen in one direction. There is another clock, a logical clock, that is tracked by the update sequence number. This doesn't happen at a regular pattern. This clock advances a tick every time a write is made to the Active Directory. Whether it's an attribute, whether it's an object, we get a clock tick. And it always goes forwards. Totally independent from system time. If you do a repadmin command, you can see the update sequence numbers that are used for the transactions that are occurring. We can also see the site name and the local system time that these events happen, and the version number. Version 1 is the first instance that that object has been written to the directory. Higher version numbers say we already have that object or attribute there. We're just doing an update. So let's have a look at a process here by which we have a user who's been created. We have 4 attributes, which we've just labelled P1, P2, P3, and P4 for the sake of it. These 4 attributes are all being written to the directory database, and they're all being done in the one transaction. If for some reason this transaction got cancelled or failed, the update sequence number would be skipped. We don't go and reuse old update sequence numbers. And we record what the property is, what its value is, what the update sequence number is on the machine where the write is occurring, version, a timestamp, and an originating GUID. Now, how many of you have actually heard of an invocation ID? Pretty much no one, I think. Oh, one person over there? All right. It's not actually DS1, it is a 128-bit long number. Those of you who have had a look at Active Directory DNS and have seen the _MS-DCs file, you've seen the domain controllers, there's a long string number. That's the invocation ID of that machine. You can also find it if you look under the NTDS settings under Active Directory Sites and Services. If you have a look under there, you can also see the invocation ID of the domain controllers. They won't match up because they're byte ordered differently, but if you do a pretty byte sort or a network byte sort, you can actually see the two are actually the same. This invocation ID is generated when a machine becomes a domain controller. And it stays, it sticks, it remains, barring other circumstances, until it is no longer a domain controller. And everything that that domain controller does, every write it makes, gets stamped with that invocation ID. If we rename a domain controller, if we change its IP address or do anything else, the invocation ID stays the same. We replicate this object to another domain controller. It's going to write those changes to its copy of the database. So it needs to update its update sequence number. It rolls that forward. And it records its update sequence number for its write of the database. But it also keeps the invocation ID of the originator of that object or attribute change. In this case, the GUID of DS1. And the update sequence number at which the originating write occurred. Keep those two concepts in mind because we're going to carry them forwards. We also have a couple of tables that the domain controllers use. There is the high watermark vector table. Now, the high watermark vector table is where it has knows its replication partners, so where am I getting my information from? And what was the update sequence number that it last had? I know that it's changing its update sequence number every time it makes a write. So if I can keep track of what its update sequence number is the last time we replicated, I can let it know where I got up to in the replication cycle. So let's say we've got the domain controller DS4. Some of the numbers haven't come out there. It's a pity. DS4, it's replicating with DS1 and DS3. We know that replication inside a site for Active Directory tends to operate in a ring topology. It's different if we go into site, but we manage it as a ring topology, so we only really need to keep track of who we're talking to. It keeps track of this for every instance of a directory database that it is taken care of. If you have global catalog servers, they keep an eye on other changes that are happening in other places, and infrastructure masters can do that as well for other domains. So they will have an extended copy of the databases or multiple naming contexts that those databases exist in. But for the sake of simplicity, we're just going to go forward and look at a single domain that's with replication occurring between it. We also have an up-to-dateness vector. Now, an up-to-dateness vector is very much like a high watermark vector. It contains a couple of extra bits of information, though. The up-to-dateness vector table doesn't just look at who I'm replicating with. It also has a record of everyone who initiated a write into the database. If you like, it's the original record. Who started it, and what was the update sequence number that they used to make that initial write. That way, I can use these two tables to determine if I'm getting something coming from this side and I'm getting a replication coming from the other side, I can use these two tables to make sure that I'm not doing the same write to my copy of the database for the same change, even though I've got it from two different sides. We cool? Excellent. Remember that replication is always initiated from the person that's trying to pull the information across. Replication is never initiated by the pusher. So at the end of the replication cycle, the person that's actually got the information with the changes has been contacted by its replication partner, has said, "Oi, give me whatever updates you've got." And the update sequence number, the high watermark vector that I've got for you is blah, 4711 or whatever it happens to be. And then I look at my database and I go, 4711 occurred there, I've had this many writes since then, and those writes haven't come from you and haven't come from someone else, so you need these ones, I'll pass them across. We can run into problems, though, where this system breaks down. How many of you have heard of lingering objects? My goodness, why? It's about a quarter of you. Lingering objects is where we've got an object on one domain controller in its copy of the database that doesn't exist in its replication partner's copy of the database, but both of the systems think they're fully in sync. I think we've all got the same details, but they don't. Now, the real problem can come with not just lingering objects, we can have lingering attributes as well. And there are a number of different ways that this can occur. One we're going to have a look in just a sec. But it does mention about garbage collection here. So let me give you a real-life situation, even without using virtualization, that can cause lingering objects. When you put a Windows 2008 R2 domain controller into a domain with 2003 or earlier domain controllers, the first thing it does is goes through and tattoos every deleted object with the is deleted, so is recycled tag. This is so that if you decide to enable the Active Directory recycle bin, it will have the right flags there to manage it. Now let's say we've got a deleted object, and we know that deleted objects get tombstoned for a period of time. The tombstones are to prevent these objects from being gone and then reappearing when they replicate with somebody else. We've got an object that's tombstoned. We have two replication partners. One replication partner goes, these objects are all nearing the end of their tombstone interval. I can now get rid of them. They're gone. They've disappeared from the database. Before its replication partner actually goes through the process of tombstoning its objects, though, a 2008 R2 domain controller comes on the scene and goes, "Hi, I'm here to make you all ready for the Active Directory recycle bin if you decide to put it in," and we all want to put it in. And it goes, "By the way, have you got any tombstoned objects? I'm sorry, I'm going to need to tattoo them." It makes a change to all these objects. Replication now occurs. The domain controller here has had changes to attributes of objects. Happen to be tombstone, doesn't matter. We've got objects in its directory that have been updated. I've got some changes that I need to replicate to my partner. Pushes those objects across to its replication partner when it asks for changes. Okay, I've got to change this attribute on this object to is deleted, and this one to is deleted, and this one to is I don't have these objects. I'll just put them here. Now the first one gets to its tombstone garbage collection and goes, "Oh, all these ones here, yep, they've reached their 180 days. I'll clear them out. I've deleted them. No changes actually occurred. When I replicate, there's nothing to replicate because I don't have any details there to replicate. This guy's still got some stuff hanging around. What am I supposed to do with them?" The only way we can really get around the lingering object and the lingering attribute problem is to do a full synchronization between machines. And we can do that, and this can cause a replication storm. If you see a replication storm happen, if you're monitoring the traffic and you see your domain controllers going absolutely bunter, trying to replicate things with each other, just let it happen. It should settle down. If it doesn't, then we've got other issues. But this is something that is known, and there are fixes. The replication procedure knows how to handle this. It just needs to say, we've got some issues here, we need to fix it up by doing a full synchronization. But we're talking about virtualization. And virtualization allows us to do something very nasty. Remember we talked about the update sequence number as being a clock that always moves forwards because time always moves forwards. When we snapshot a machine, we're capturing the update sequence number that is in existence at that time. Time doesn't stand still though. The snapshot is sitting there quite nicely, and the update sequence number continues to increase. If we reapply that snapshot to the machine, what we have effectively done is roll back time. We now have a situation where the domain controller could allocate already used update sequence numbers for new changes. Now, it doesn't know a change has occurred, so it's going to be using its same invocation ID to tattoo those, to make sure that those changes are recorded. Let's visually look at this. We have Virtual Domain Controller 2. It's happily burbling along. It's made some updates from 101 to 200, and the person that's looking after our virtual environment, they're not the Active Directory domain controller, they're somebody who's managing our VMware infrastructure or our Hyper-V infrastructure or our Citrix Zen server infrastructure. And I'll snapshot the machine because that's a really good way of providing some fault tolerance, some disaster recovery. Cool. I snapshot it. Update sequence number 200. Time goes on. The update sequence number changes and replication occurs to DC2. DC1. DC1 says, give me all your changes. I've now got a high water mark level for you at 200. Time goes on. VDC2 makes more changes. They're now up to 350. Replication occurs. DC1 says, what have you got above 200? And it goes, right here, 201 to 350, have at 'em. It then writes all of those issues, all of those changes into its copy of the directory database, including the invocation ID of VDC2. And then VDC2 falls over. Bless you. Our virtualization admin says, I know how to fix this. We've got a snapshot of when the domain controller was working properly. So I'll just roll back to that. This is cool because we know that Active Directory is a multi-master situation and they'll just replicate the changes back again. This is cool. Until the next time the replication occurs. Now in this situation, VDC2 has gone, right, my update sequence number is 200 and I'm getting some more changes here, so I'll allocate some more numbers and I'm up to 300 and DC1 comes knocking. All right, give me all your changes that have happened after 350. 350? How can you have 350? I haven't got to 350 yet, I'm only up to 300. Oh. For you to be asking me about 300, 350, and me to think that I've only got up to 300, I must have been rolled back. I must have lost part of myself. And at this point, VDC2 goes, la 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 la. It enters a self-imposed exile. It won't talk to anyone. It goes, I don't know what to do. This is actually not bad because we have identified there is a problem. We know there are going to be lingering objects between VDC2 and DC1. We can fix it. But what happens if VDC2 gets really busy after it gets brought back and instead of getting to 300, it pushes past 350 and gets to 355? DC1 comes knocking. Give me all your changes from 350. Oh, that's easy. I've only got 5. Here you go. We're all happy. Cool. There's no rollback detected. As far as VDC2 is concerned, everything's happy. We don't actually know there's been an issue. Our virtualization admin is happy because they've managed to get the domain controllers back talking to each other, and you're none the wiser. How many of you are backing up your domain controllers? Fantastic. How many of you are using a solution that's been certified to work with Active Directory? Great. If you're not, be scared because the same thing can happen. Whenever a domain controller is restored using a backup solution or a restore solution that's certified to work with Active Directory, it sets a flag in the registry to say, oi, you've been backed up and restored, which means you've gone back in time, and that's going to break one of the key assumptions of Active Directory in that time always goes forwards. So what do you need to do? You need to reset the invocation ID. The invocation ID that is supposed to last from birth to death for a domain controller is now no longer a good way of you being able to tell what you originated, because you don't know in your copy of the database everything that you've written. And the only way to get that information back into your copy of the database is to say, I'm not me anymore, I'm somebody else. And next time I replicate, my replication partners go, who the heck are you? Oh, that's okay, we'll talk to you. That's all right, we're all one big happy family here. What's your invocation ID? Cool, I'll make a record in my table and we can talk. And by the way, I've got all these records in my database. Now, what have you got from me? Nothing? Okay, we'll start from 0 here. And it pulls up the invocation ID of what it used to be. And it goes, right, I've got some stuff that was written by DS1. That's not you, so here you go. And DS1, I don't know who that is. I'll take that. It obviously wasn't me, so I'll write that into my database, and we're good. If we don't have a backup restore solution that's AD aware, are there any fixes? Yeah, go and buy one. Now, I'm not suggesting that you do this. This is a last resort situation. If you have a domain controller that has fallen over and you need to resort to a snapshot, a past snapshot, or you need to resort to a restore from an old system, take it offline. Don't let it replicate. Take it offline, do the restore. It cannot replicate out. And then there is, under the current control set NTDS settings, there is a restore in progress switch, and you need to turn it to 1. You set it to 1, restart the machine, and it goes, oh, I recognise that. That says I've gone back in time. Therefore, I need to reset my invocation ID, and therefore I'll lose all my past identity, but at least I'm not going to have lingering objects and other yucky stuff. So that's one little way around it. Because we're resetting the invocation ID, we're going to have a full synchronize of the database, which is going to take a heck of a lot of time. So last resort option, please. Do not be suggesting out there on Twitter, especially, that I recommended this as an approach for. What about physical to virtual? General rule here. Please, 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 please never, ever, ever, ever have a physical domain controller and its P2V counterpart on the network at the same time. Should never allow that to happen. Excuse me. If you're going to P2V a domain controller, it should be done as an offline task. You shouldn't be having those machines connect to the network while you're doing P2V. All right. If you are going to do P2V, Microsoft recommends using System Center Virtual Machine Manager. It has a number of little checks in place to make sure that all the right bits and pieces have been switched. And you might think, well, hang on, it's just the invocation ID, isn't it? Surely if I just reset the invocation ID, that should be enough to make sure that these are happy to work together? No. Now, we've talked about the invocation ID as far as replication is concerned. There's actually some other settings inside domain controllers that provide them with clues as to their identity that aren't changed when you just do a reset of the invocation ID. And if you have two of those machines sitting on the network at the same time, even if they've got different invocation IDs, there's still going to be fights and problems occurring. So please don't go there. What about read-only domain controllers? They don't make writes to the database. We should be cool with those. In theory, you should be. However, if you have a problem, who are you going to ask for support? Microsoft? That's a good call. Microsoft Support Services won't actually support problems if you have cloned read-only domain controllers. So we can't give you a solution of how to do domain controllers properly. What I'm trying to do is tell you what not to do so that you don't run into that problem. We've got an issue, we need to go to support services, and all of a sudden you get told, oh, no, you shouldn't have done that. So we're telling you, you shouldn't have done that here now. So can you clone read-only domain controllers? Yeah, don't do that. And we have a number of miscellaneous considerations to finish things off. So first thing, time synchronization. You all follow Microsoft best practice? Yeah? Don't sound very enthusiastic. Did you know that best practice changes over time? Fantastic. So what was best practice when somebody came in and checked your system 2 years ago isn't necessarily best practice now. And Microsoft have changed their mind, sort of, on the time synchronization bit. So the general philosophy now, as far as best practice is concerned with the time synchronization for virtual environments, is that you just let it do its thing. But what you might want to do is disable the virtual machine integration components between the guest operating system and the host operating system. The reason why is because when a virtual machine polls for time sources, if you have the integration components set, the host will reveal itself to the guest as the equivalent of a real-time clock. And chances are that the host that you are running your virtual machines on isn't really a real-time clock. Have them both pointed to the same time source is a good thing. Have them pointed to a physical domain controller somewhere. There are some thoughts about even having the underlying host operating system also being a domain controller. That can cause other issues. You obviously can't do that if you're running Microsoft's Hyper-V server, which is pretty much server core and Hyper-V service and nothing else. So, are there issues concerned with trying to synchronize between the host and the guest machines? There can be. Pretty much the time service, it's not ideal. The algorithm that is used to work out how we should be doing time is not ideal, but it tends to work. We have a bit of leeway to play with. Let it do its thing, point it to an equivalent time source. You could even have it going to multiple time sources if they're both military grade. So if they're both real-time clocks, we should be fine. Other security concerns around domain controllers in a virtual environment. I mentioned this morning that there was a situation quite a few years ago where Australian Customs had outsourced their IT, and some people came in dressed in suits and said, we're here to look after the domain controllers, let's look after the servers. All cool, yep. They're dressed in suits, therefore they must work in IT. That's probably why they outsourced their IT. And these guys walked out with the domain controllers. That's fairly easy to detect pretty soon after the event when it's a physical machine. Not only do you have people asking the security guard for a hand lugging stuff out to the car, but it leaves a big gaping hole in the middle of your rack. If, however, you've got somebody who's copied a virtual hard drive of your domain controller and stuck it on a USB key and put it in their pocket and walked out, how would you know? Your virtualization admin, whoever is responsible for managing your virtualization environment, could well have access to that VHD. So just copy the file. Right? That's where the file permissions are. Active Directory's got nothing to do with it in this case. So security concerns around loss of identity, loss of our Active Directory database are increased in a virtualized environment. And don't get me started on going to the cloud, particularly if it's hosted outside the country. We have other issues where we could have elevation of privilege attacks from the host administrator to looking after being able to make changes, mounting the virtual hard drive onto another machine. You know that Windows 7 makes it really easy to mount VHDs? In fact, that's one of the benefits of using VHDs, is that we can actually inject driver updates and hotfixes and other things onto these VHDs without having to boot up the machine. Fantastic. It's also an attack vector. So in these situations, maybe server core is a good example, good way of doing it. Reduces the attack surface for those machines. And also try and make sure that the privileges that are on the host don't overwrite the privileges for the guest virtual machine. Some people might say, oh, there are performance issues in having domain controllers in a virtualized environment. It used to be the case, virtualization technology, doesn't matter who your vendor is, has improved to the point that, especially for domain controllers, whether it's virtual or physical, is not really an issue. It should be pretty much the same. How about we go all virtual? How about we have no physical domain controllers? Now, there was a general rule of thumb that said you should have at least one physical domain controller for every domain. Now, for some places, that's going to actually be a real pain in the neck. We're going virtual because we're trying to save money here and manage our resources better, but you're telling me that we've got to have a separate physical machine for every domain that we're running? This is something for you to manage, okay? If you can get away with it, fantastic, but I don't know that it's really necessary. If you are backing up, and there's a good number of you are, backing up your domain controllers properly and are aware of the issues that can be occurring if you're cloning and snapshotting and doing things like that, you can get by with very, very few in the way of physical domain controllers. Don't put all your eggs in one basket. Don't have all your DCs running on the same physical host, because if that goes down, bye-bye. Some other little issues to be considerate of. Forcing updates to writing. You might have your domain controller that's trying to say, I'm going to write changes when they come in to the disk straight away. I'm not going to cache them, because I know that if I have a problem and I've recorded that I've completed that transaction, but it hasn't been committed to disk, I'm going to end up with lingering objects. I'm going to end up with major problems. So I'm going to make sure as a domain controller, I'm going to turn off disk caching and go straight to disk. However, your host is going, you know what, all this I/O is giving me a headache, so I'm going to cache it and just write it in batches. We've got a disconnect here, folks. What happens if the domain controller thinks it's been written to disk, but it actually hasn't? So in this case, try and marry up the settings, the I/O settings for your host, your virtual host, with the settings, the I/O writing settings for your virtual machines. The machines can run hot. We've seen this happen in some data centers where we're overloading here. We'll just shut down some virtual machines. We don't necessarily want the underlying host to be playing God over our domain controllers. Antivirus issues on the host. I'm trying updates here. I need to lock these files while I check it. I'm locking the VHD, I'm preventing writes to it. Meanwhile, your domain controller is completely unaware that under the covers, somebody else is preventing writes to it. So it's going, why can't these things stick? I'm just not able to do anything. And snapshots and disk space. If you are running snapshots of your machines, you would know that they take up extra space. This is where we go into management of the directory database, doing defragmentations and other things to try and reduce the disk size, because we know that Active Directory databases can blow out in size quite regularly. And if you're doing snapshots of those, you are compounding those issues. So it is even more important to remember to do regular defragmenting of your Active Directory database if you are doing snapshots of them in a virtualized environment. So to recap, as we finish off, should we clone non-domain controllers? Sysprep them. Yes. If you don't sysprep them, yeah, you can have problems, but it's not going to affect AD and Windows generally. Should we clone domain controllers? Absolutely no way in hell. Please don't go there. What about Hyper-V host snapshotting on domain controllers? If it's writable, if you're doing writable snapshots of writable domain controllers, you are practically guaranteeing a USN rollback situation, which is going to result in lingering objects. For read-only domain controllers, you might be able to get away with it, but remember that you're going to be on your own. It's not supported. And for the time synchronization service in a virtualized environment, just disable the integration components so that the host clock isn't telling the guest that it's the equivalent of a real-time clock. For those of you who came this morning and did evaluations, thank you very much. Please fill in evaluations for this session as well. 1's bad, 5's good, and it'd be really nice if an Australian beats a North American for the best presentation. I'll leave that entirely to you. By the way, yeah, I know you're there. It's like fishing. If you are going to write comments in the evaluations, what I've done for my first session, and I'll do it for this session as well, please, I do value the comments that you write. If you have problems or issues or questions about things or whatever, and you want to pop them in the comments, I will try and address them as much as possible in Twitter. And I'll use the hash SVR412 hashtag for that. If you've got other questions, and I haven't been keeping an eye on 23 new tweets, I'll also go through the Twitter feed for hash SVR412, and if there are any questions that you've posted there, I will also reply in Twitter, the expectation being that if you have tweeted them, you can read Twitter. We have about 10 minutes before the time is to finish. I know it's a big room and some people want to have a bit of a stretch before their next session. So what I will do is I will stay here and I'll keep the audio on so that if there are questions, we can keep them recorded in the audio. If you want to go, fantastic, thank you. Just the last couple of slides. Be involved in the Tech Quest, and the slide decks and the recordings will be available in Schedule Builder when they've been put up, and there are other resources to go to. But other